That's right, boys and girls. It's your favorite time again. Algebra 2 fun. This is Mr. Meyer at the Way Happy Studios in beautiful Livermore. And we are going to talk about adding and subtracting rational expressions. And then we're going to even add a little complex fractions in there. So sit back and enjoy, and let's see what we can do. So example 1 here, we're going to cruise through this real quickly because we are going to add and subtract fractions. And you remember when you were a little kid that adding fractions was pretty simple as long as they had a common denominator. And if they did, you added it together and then you were happy. Same thing goes here. You got to look at that denominator. We got to make sure that denominator is common, which it is. And if so, we can just add it together. So for me, this is x minus 3 plus x minus 2 all over that common denominator, x plus 4. Clean it up a bit. What is that? 2x minus 5 all over x plus 4. And you are done. Now, what about this undefined thing? Remember, no zeros in denominators, so we got to say x cannot equal negative 4 because we don't want that denominator to be a 0. And golden in A. What about B? Same thing. Look at those denominators. Are they the same? Yes, they are. So we can just write this as one big fraction. 3x minus 4 minus, now be careful, all of 6x plus 1. And that's over x squared plus 1. So there's a little bit of trouble there. That negative has to be distributed all the way through. You'll fall for it once and then probably never again. So hopefully here you see it and you're not scared. First thing I would notice is 3x minus 6x is negative 3x. Negative 4 minus 1 is negative 5. Yeah, it's negative 1. Negative 5 all over x squared plus 1. There is my answer. Sure, you can clean it up. Take the negative 1 out and have 3x plus 5. That would be fine too. It wouldn't do you any good, so that's probably why I wouldn't do it. What about what values are not allowed? So set the denominator equal to 0. And if I do that, I get x squared plus 1 equals 0. I get x squared equals negative 1. Ooh, x equals plus or minus I, square root of negative 1. Well, that's okay because those aren't real numbers. So we don't have to worry about our excluded values because they're not real. And so therefore we are done. And that is how I add or subtract using like denominators. Now what if the denominators aren't the same? That's when you got to worry about the least common multiple, or what a lot of us will call a common denominator. But first, let's talk about least common multiple. And here's your hints. To find the least common multiple, factor everybody. Factor them down as much as you can. You see right here we factor it. And then if anybody repeats as a factor, use a power. And why is that important? Because what you're going to do is when you find the least common multiple, you will list all the different factors, and the ones who are the same, you'll use the highest power of that common factor. So that's why we like to mention that. You use the highest power. So let's try the least common multiple here. If you look at example 2, you'll notice that this factors down to 2 squared x squared y cubed, and this guy factors down to 2 times 3 x to the 4th y to the 5th. And now to find their least common multiple, everyone has to be represented. So let's start off with the 2's. There's a 2 squared and a 2. Well, wait a minute. 2 squared would be our biggest choice there because they're both the same power, and therefore we're going to use the largest exponent. There's some base, I'm sorry. Now 3 needs to be represented, so we're going to times 3. Now we have the x's. Now here's an x squared and here's an x to the 4th, so the largest power would be x to the 4th. And last but not least, the only one's not highlighted there, the y's. We have a y cubed and a y to the 5th. We need the highest power again, so y to the 5th. The least common multiple would be, what is that, 4 times 3, 12 x to the 4th, y to the 5th. There's your least common multiple. Also, if these were denominators, that would be your least common denominator, and that's where this is really headed. Again, I'm going to factor over here on B. So what two things multiply to negative 3 that add up to negative 2? I'm thinking that's negative 3 and 1. So we have x minus 3 and x plus 1 as our factors for the first one. The second guy, he looks like what two things multiply to negative 6 that add up to negative 1? So that looks like negative 3 and positive 2 to me. So x minus 3 and x plus 2. And now remember what they have in common. We'll take the largest power. So they both have an x minus 3 in them to the first power. So I'm going to keep x minus 3 as my factor. Then this guy needs an x plus 1, and we need all the factors of everybody, not just the ones they have in common. So he needs an x plus 1, and this guy wants an x plus 2. And there is my least common multiple. And that's how you find least common multiples. And now we will do that. But first, let's ask you a question. So good luck. All right, keep up the great work. Now let's combine those two ideas. So in example 3, we have to add two fractions together. But oh no, their denominators aren't the same. So we need to find the least common multiple of the denominators. And then that way we can make them the same. So here we go. Again, factoring. So I'm going to factor the bottom of this guy. He looks like x plus 4 and x minus 1. And over here I have 2x over x plus 4. So you can see their denominators are not the same. So let's make them the same. And so what would the least common multiple be? Well, the first guy wants an x plus 4 and an x minus 1. The second guy wants an x plus 4. Ooh, they had it in common, so the first power. So that is our least common multiple, also known now as our least common denominator. So the first fraction is good to go. He's got that denominator. The second fraction, not so lucky. He needs an x minus 1. Now we can't just give him the x minus 1 like that. That's totally illegal because you've just added it to a denominator and you've just whacked everything out. It's not the same. However, if you give it to the top and the bottom, so you're multiplying by that fraction, in essence, you're just multiplying by a big number 1, right? That's just a 1. X minus 1 over x minus 1 is the number 1. Multiplying by 1 changes nothing. So that's what makes it all legal. The only good news now is that you have a common denominator for both of these fractions. And we've already seen before that that's a good thing, right? Up in example 1, that made our life a lot easier. So now that these are together, I can just add them together. So I have x minus 3 plus 2x over, or times x minus 1 all over x plus 4, x minus 1. Keep that denominator that you found. Now clean this bad boy up a little bit, right? You got to distribute this to both of them. Notice that minus sign means I got to distribute the 2x through. So I have x minus 3 plus, now that's 2x squareds minus a 2x all over x plus 4, x minus 1. And I can clean this up a ton now. 2x squared, what is that? Minus x minus 3 all over x plus 4, x minus 1. I'm a little nervous that that top might factor, right? I had 2x squared, I had the minus x, the minus 3. A little nervous it might factor, so let's see. Remember, I use bottoms up, which is kind of weird. So if you forgot it, let me show you what it looks like. I multiply the outsides, so that's negative 6, and it's got to add up to negative 1. I do know something. Negative 3 times 2 will fit that bill. Now here's the weird part of bottoms up. I have to divide them both by the leading coefficient. So in this case, 2. And what that numerator factors out to is x plus 2 over 2. So what I would call x plus 1. And the other factor, maybe I should write that, this would be x plus 1, and this one would be x minus 3 over 2. So we bring the 2 out, that's 2x minus 3. It turns into that. So that's the other factor. And notice that's over x plus 4, x minus 1. Oh, bad news. Nothing canceled. So I was finished. And I didn't need to go that extra step. But it's good that I checked. I feel a whole lot better. Oh, yeah. Maybe you're screaming, what about the undefined ones that you always forget to mention? You're not allowed to forget. So what is undefined? X cannot equal negative 4. X cannot equal 1. And there we have it. When you don't have a common denominator, you make a common denominator, you add them together, and you're done. Remember, two fractions added together should still be a fraction, unless something canceled at the end there. But I got my answer as a fraction, and it is beautiful, and I am happy. Let's try another one just to make sure you're not feeling too spooked. So again, factoring, I have x over x plus 2 plus a negative 8 over, factoring that as x plus 2, x minus 2. Go ahead and look for a common denominator in this. Looks like my common denominator, or multiple, the first guy wants an x plus 2, which they both have. So we'll take the largest exponent, which is 1. The first guy's done. The second guy says, I also want an x minus 2. We said, got it. Now go over and make sure they both have that denominator. Second guy does. He's good. This guy needs the x minus 2. And so I give him the x minus 2 to top and bottom. And we're ready to go. I can distribute the x into this guy because of the negative sign. So that is x squared minus 2x plus a negative 8 all over x plus 2x minus 2 as my common denominator there. Well, again, I'm a little worried. I want to factor that top. Does anything multiply to negative 8 that adds up to negative 2? Yeah, I think that's x minus 4 and x plus 2 all over x plus 2, x minus 2. Sweet! There's my answer. But wait! Good news! Somebody canceled. So therefore, my final answer, x minus 4 over x minus 2, that is our final reduced fraction. Done. Oh, what about excluded values? Now again, some people might think that because that one canceled, we don't have to worry about the excluded value, but that is so wrong, right? That you have to go back and look before you canceled anything, who was in denominators. And right here, I have to say x cannot equal negative 2 and x cannot equal 2. Now you might think, oh, why would I have to do that? It canceled. Well, remember, in the very beginning, up here in the problem, if we would have had a negative 2, that would have been bad. And so therefore, those restrictions will hold off the entire time. And so those are my restrictions for this guy. And there's your answer. Enjoy one. All right, I will warn you that subtraction is always the tricky one. It's done the same way, and I probably could have done it in that last clip, but I didn't. So here we go. First thing I would do is factor. I'm going to factor out that 2 and be left with x squared minus 15. Darn it, I was hoping that factored. Ooh, difference of squares in the bottom. X plus 3, x minus 3. And then we have minus an x plus 5 over an x plus 3. So again, all we care about right now is the common denominator. And so I'm going to look to see if they're the same, and they're not. And you can probably tell by now that this guy is missing an x minus 3. And so you will give it to the top and bottom because that is totally legal. And now their denominators are the same. Well, now we can finally combine their numerators. Now that factoring of the numerator I think is going to haunt me a little bit here. I was hoping it would cancel. But look what I have. I have that as my numerator, and on the bottom I have this. Now be careful. Some kids totally tempted to cancel the x minus 3's, but you can't. This little subtraction sign is holding everybody together. That one little subtraction holds the entire unit together, and so nothing can be ripped out of it. So we need to simplify it down a little bit. So I think I'm going to distribute this 2 back in, and I think I'm also going to FOIL these two guys to see what's going on. So here I go. 2x squared minus 30 minus, and then the foiling of that will be x squared plus 2x minus 15 all over x plus 3x minus 3. Now hopefully that didn't scare anybody, the foiling there. If you're wondering how that foiling went, I'll do it real quick here in a box. I have x plus 5 and x minus 3. And remember, we just multiply x squared, we get 5x, we get negative 3x, and we get negative 15. Right there's where the 2 came from. Probably the most commonly missed thing when people do algebra tests. All right. Now let's combine like terms. I got a 2x squared minus an x squared, so that gives me an x squared. I got a minus 2x. Ugh. I got a negative 30 plus a 15, so that's minus 15 all over x plus 3, x minus 3. And I think I'm done, except for that top looks like it factors. It factors 2x minus 5, x plus 3, all over x plus 3, x minus 3. And oh my gosh, here we go again. We have an x plus 3 canceling. Our final answer is x minus 5 over x minus 3. But our excluded values, x cannot be negative 3 and x cannot be regular old 3. And there's my final answer. Nice, right? So be careful about that negative. They're the ones that always mess people up. So make sure you distribute that negative through. All right, last but not least, probably the spookiest thing, but also the most fun. It's called the complex fraction. And a complex fraction is when you have a fraction over a fraction, and you've done these before. You've done these when you were little, and it looked really spooky. In fact, here, let me do a generic one. Say you had 4/3 over 2/5. You'd be like, ah, crazy, I don't know what to do. Not true. You've seen this before, right? Just we used to write it like this: 4/3 divided by 2/5. That's all a fraction is. It's just a division problem. And now you probably are on, oh yeah. I call it copy.flip. I don't know what you guys call it. But I got to copy the first one, change it to dot, flip the second one, and now you just multiply straight across. 20 over 6, or I could have reduced then, was that 10 over 3? And there's my final answer when I was a little kid and felt all impressed. Well, same thing goes here. Make sure you have a fraction over a fraction. That's your first thing that you have to worry about, and in this case I do. So now I just copy the top, change it to dot, and flip the bottom. And lo and behold, I'm feeling pretty darn good. I would look to see, now remember, this isn't adding or subtracting, so common denominator, out the window, no one cares. And now you can just say, all right, multiply the tops together, multiply the bottoms together, see if anything cancels. In this case, they don't. So I would just have x plus 2 times x plus 5 all over x minus 1, x minus 3, and I am done. That is it. Now the big catch. What are the excluded values? Oh, they said assume that all are defined. Well, if you wanted a heads up, which ones are excluded? 1 would be bad because that was a fraction. Negative 5 would be bad. And at the same time over here, 3 is bad and 1 again. So you can see there would have been a lot of excluded values that we were not allowed to have in this problem. And that, my friends, is it. We will do a little more in class, and I will see you tomorrow, so stay happy.